Okay, now as you can see, I've already filled out the table of values for the function, the new function, y is equal to 2x squared. So the only change from y equals x squared here, which is the graph that's drawn in blue, the only change between that one and this one is there's an additional 2 out the front. So we saw here in a general form, it was referred to as a, so the a has just been replaced with a 2. So we do our x squared first because order of operations says you must do your power first, get the answer to that and then multiply it by 2. Well, since I've got this table here, which is x squared values, I've just taken those and times them by 2. 9 2s are 18, 4 2s are 8, 1 times 2 is 2, 0, and 2, 8, and 18 on the other side. I'm going to graph them now, and I'm going to graph them in black. And negative 3, 18 is off the graph. So I can't actually plot negative 3, 18. I can plot negative 2 and 8. Negative 2, 8, it will be I'm not sure. Hopefully I'll be able to pick that up in a minute. Oops. Sorry about that. I seem to have got it back to where it should be. And I haven't done a very good job because I find it really difficult on the Surface Pro to get anything very smooth going on, drawing by freehand. But that would be your graph of y equals 2x squared. Now, you're often asked to compare your graphs. So we'll always be comparing to the basic y equals x squared. So basic y equals x squared, we say, is just our basic parabola. The moment you can see you put a 2 in front, really the parabola, we would say, has become thinner. And the bigger number that you put at the front, if I was to put a 10, then I would have a, Yeah, so there, like I was saying, if I had a 10 in front of the x squared, positive number, then the graph just gets, the bigger that number is, the skinnier the graph gets. Now, I've also gone on and filled out the table of values, now putting a fraction, a number between 0 and 1, in front of the x squared. So remember, these graphs we've just looked at are numbers bigger than 1 in front of the x squared. Now we'll look at the fraction. So this is just a half of the x squared. So again, you must do the power part first. You'd have to square your negative 3. And remember, we've got those values already up here, squaring negative 3. And then I want a half of it. So a half of 9 is 4.5. And a half of 4 is your 2. Half of 1 is a half, 0, and then the same repeated on the other side. So graphing those is at negative 3, it's only 4.5. So it's approximately here, and I'm not sure how well this is going to cooperate. Oh yeah, that's quite good. And at negative 2, it's negative 2. And at negative 1, it's a half. Oops. And I'll just pause the video and attempt to sketch that one. It's not a very good sketch, but hopefully you're getting the idea that now the parabola is going flatter compared to the standard y equals x squared. So like I said before, we compare everything to the graph of y equals x squared. So we get a flatter graph. Now, we're going to also have a look at the negative. what happens, what colour can I go to? Yep, we'll go to red. What happens when we put -1 in front of the x squared? Well, like I said before, you still do squaring all the numbers, which are the values up in that table. But now you put a minus in front of each one. So we've got -9, -4, -1. So coming back to the graph at -3, we're down here at -9. At -2, we're at -4, -1, we're at -1, and then the same is repeated on the other side. And so I've got a nice little upside down parabola, which is meant to be about the same curve as the blue one above. Okay, it says here, the graph of y equals ax squared is a parabola or U-shaped curve. You might see it referred to that. If you haven't come across that before, please make a note of it. So 2 names, parabola or U-shape, and the graph of y equals minus ax squared is upside down. Is an upside down U-shape. Okay, let's keep going. We've got a few more things to fill out. These parabolas are what we call symmetrical. Remember, I was just saying that to fill out the table of values, you get the same numbers on either side of the 0, and the 0 represents the y-axis. The turning point is called the vertex. Please learn these. If the terms, like I said earlier, or in the other video, so that when I'm talking about them, you actually know what I'm referring to. If A is positive, the parabola is concave up. More terms for you to be familiar with. And if A is negative, it's concave down. The vertex of each of the parabolas above is at 0, 0. The graph of y equals ax squared always passes through the origin. These two things are the same. They're just the coordinates for the name origin. If a is a number bigger than 1, the graph becomes thinner. And if a is the number between 0 and 1, like the fraction we did, it becomes flatter. Overall, the effect of adding a number in front of the x will either make the graph thinner, steeper, sometimes people refer to it, or flatter. A parabola is symmetrical. Now this is just repeating the features because they're important about the axis of symmetry, and the axis of symmetry is the y-axis. If you fold along the y-axis, the graph nicely matches. The turning point is called the vertex. Positive A, it'll be concave up. Negative A, it'll be concave down. And I'll stop the video there.